Hello everyone, thank you for watching this video in place of our lecture today. We have a last section to talk about in this first unit, and it is 8.5, but the first half of it, so 8.5 little a, which is on solving certain types of equations. So we're going to be solving equations throughout the semester. I guess what it means for an equation, we haven't really looked at them together in this class. So you don't have to write this down if you know what it means, but an equation basically is something that has an equal sign, and the left side and the right side have to be the same as each other. So for example, you can have something as simple as 3 plus 5 equals 8, or maybe you have something with a variable in it like 4x plus 7 equals 19. We think of the x if we have it in an equation, which we will most of the time, or y or whatever as a variable or unknown. And we're going to be wanting to solve equations, which means to find the value of x that makes the equation true. We could call these solutions or roots, and the act of solving the equation means to find those solutions. So here, just to make sure we understand what it means, x plus 4 equals 9 is an equation. And here are two proposed solutions to the equation, x equals -1. And so if you plug this in for your variable x into this equation, you get -4 plus 1, which is 3, and that's not equal to 9, right? So this is not a solution to the equation. But if we look at our other proposed solution here, x equals 5, when you plug that into the equation, 5 plus 4 on the left does equal 9. So we do have some things as solutions and some as not. So this first type is called a linear equation, and that's what we will just review solving to start. So some simple steps in solving linear equations. We'll just isolate the x terms on one side of the equation. This will involve using addition and subtraction, and you want to treat both sides of the equal sign the same, right? So whatever you do to the left side, you've got to do to the right side. And then once you have all your x terms together on normally the left side, although it doesn't matter, and numbers all on the other side, then you use multiplication or division to get like 1x equals, or just x equals, and then a number on the right, and then that is your solution. So we want to do the opposite of PEMDAS, or opposite of order of operations, to undo everything that has been done to the variable. So in the first example, we have 3x plus 4 equals 13. And the multiplication here, right, is between the 3 and the x, then we have plus 4. So normally like PEMDAS, right, parentheses, exponents, multiply, divide come before add and subtract, but we're undoing that. So we want to isolate the x terms, and that will be by subtracting 4, doing the opposite of plus 4 on the left side. So these cancel out. But if we do that on the left side, you can kind of think of this as like balancing left and right side of the equal sign. Then we also have to do it on the right side in order to maintain the equality. So this cancels out, adds up to 0. Right? On the left, we have 3 times x. And on the right, we've got 13 minus 4, which is 9. And then to fully solve this, we want to undo the 3 times on the left side. So the opposite of times 3 is divide by 3. Divided by 3. And so we end up with 1x on the left, or just x equals, and then 9 divided by 3 is 3. So here's our solution to that equation. And I won't do this all the time, but you should check your answers just to make sure. So we'll plug in the 3 into the equation for x, and we'll see, are these equal to each other? Okay, so 3 times 3 is 9, and 9 plus 4 is 13. So we did find a true solution. All right, that was kind of simple. Number 2, we have 2x minus 2 equals -3x plus 13. Now here we have x's variable expressions on the left and the right. So it doesn't matter the order that you kind of do this in, but I want to get just x stuff on the left side and then numbers on the right side. or, just one side with x's and one side with numbers. So I'm gonna maybe put the numbers together first. So I'll do +2 at the opposite of the -2 on the left, just to move the numbers over to the right. And what that will give us on the left is 2x. We still have this -3x, and then 13 plus 2 is 15. And then we gotta get the x's together on the left side. So instead of -3x or -3x, I'm gonna add 3x to both sides. And that's gonna cancel out the 3x on the right side, and we'll be left with just 15. And then 2x plus 3x, these are like terms. So we've got 5x total. And then the last thing is to undo the times 5. So we'll divide by 5. And that will give us 1x on the left. Sorry, I gotta move this down. And then 15 divided by 5 is, of course, 3. So there's our solution, x equals 3. In number 3, we've got lots of fractions to work with here. And you could do the same approach that we've been doing, although I know that many of us don't want to deal with fractions if we don't have to. So here's sort of a technique to get rid of all of the fractions, and it's called clearing the fractions. So with equations, you can do anything to one side as long as you do it to the other. And you want to think of all of your denominators that appear in your equation here. So we've got 3, 6, 2, and 6. And there's a number that you can multiply through on the left side and the right side that will basically cancel out all of your denominators. And that number is the common denominator that you would get if you were to add all these together. So I'm going to say we're going to multiply by the LCD, least common denominator, over 1. So in this case, 3, 6, and 2 all have least common denominator that you would get if you were to combine this together is 6, right? It's the smallest number that they all can multiply into. So I'm going to multiply on the left side by 6, which is the LCD, over 1. And I'm going to multiply on the right side by 6 over 1. Now what that's going to do is force me to distribute this into the left side. And so when I write this out, I'll have 6 over 1 times 2/3 x minus 6 over 1 times 1 over 6 plus 6 over 1 times 1/2 x. On the right side, same thing, we're going to have to distribute this in to the parentheses. So I'll have equals, I'm going to put it in the beginning. Even though it's on the right side, we can multiply it on the left. So 6 over 1 times 9 over 6, and then plus 6 over 1 times 2x. I'll just move this over. Okay, now the canceling can happen. So, whoops, sorry. The 6 here and the 3 here would divide to have a 2. The 6 and the 6 here divide to give us 1. The 6 and the 2 here, 6 over 2 is 3. The 6 and the 6 here give us 1. And then on this last piece here, we have really over 1 on the 2x, so we'll just have a 6. Nothing to cancel out there. There was no denominator anyway. So what that brings us to is an equation without fractions. So we have 2 times x. So altogether that gives us 4x. Okay, then we have minus. This here was like 1 over 1, 1 over 1, all of that multiplied together gives us 1, so minus 1. Then plus 3 times 1 times x, so that's plus 3x. Then equals, over here we have 1 times 9, which is 9. And then 6 times 2x, so that gives us plus 12x. Sorry, just gotta make some extra space here. So, yeah, now this looks better, right? Because we don't have any fractions to deal with here. So now we'll do what we were doing in the previous two equations. So I don't know, on the left side, I do want to simplify where possible. So I've got 4x and 3x. I can add those together, right? Those are like terms, so that gives us 7x, then minus 1. Nothing to combine on the right side, so we'll leave it like that. Then I want to get the numbers together on the right side and the x's together on the left side. So I'm going to bring the 1 over to the other side. And if it's okay with you while I'm at it, let's do negative minus 12x on the right and just combine those together on the left side. Right, so on the right, I'll end up with 9 plus 1, which is 10. And then on the left, I've got these canceled out, so I have 7x minus 12x. And 7 minus 12 is negative 5, so I've got negative 5x. All right, then the last thing is to divide by negative 5. That will give us a 1x on the left, and 10 divided by negative 5 is 2. Positive divided by negative is negative. So here's our solution of x equals negative 2. All right, moving on, where's number 4? Over here. Another linear equation. We've got 2 minus 5 times x plus 5 equals 3 times x minus 5 plus 8. Now these x's here and here are like bundled up in the parentheses. So before we do anything here, we're going to have to distribute the negative 5 and the 3 into the parentheses. Remember your order of operations, you can't do 2 minus 5 first. This multiplication comes before this minus. So we really have to do this multiplication first. So we'll have 2 minus 5x, and then negative 5 times 5 is minus 25. Okay, bringing the 3 into the parentheses, we'll have 3x minus 15, and then we still have that plus 8. Right, now we can combine some things together on the left and on the right. We have 2 minus 25, which is negative 23. And then we still have negative 5x. Then on the right side, we can also combine the constants together. Negative 15 plus 8 is negative 7. All right, now we will get the constants on the right. So I'm going to do plus 23 to bring that over to the right side. And I want to get the variables on the left. So I'm going to do minus 3x to both sides. So equals, we'll keep coming down. On the left side, we've got negative 5x minus 3x, so we'll add the negative 5 and the 3 to give us negative 8x. And then negative 7 plus 23, I believe is positive 16. All right, then last here, this is negative 8 times x, so we want to get 1x. We'll divide by negative 8 on both sides, and 16 divided by negative 8 gives us negative 2. So there's our solution to this equation. All right, one more of these, and I'd encourage you to pause this and try on your own to see how this is going for you. We've got 8 minus 3 times 16 minus 5x equals 5 plus 5 times 2x minus 7. So same thing here, we got to distribute, get rid of the parentheses on the left and on the right. 3 times 16, I believe, is 48. This is a negative coming into the minus 5x, so this will make this plus 15x. This 5, right, we can't do this plus 5 first. Multiplication comes first when we are having to simplify an expression. So we'll have to bring the 5 in to give us plus 10x. And then 5 times 7 is 35. All right, same thing here. We're going to combine some numbers on the left and on the right. 8 minus 40 is negative 40. 5 minus 35 is negative 30. And if you wrote this as, maybe 10x minus 30, that's okay. It doesn't make a difference. But at this point, I want to get the x's on the left and the numbers on the right. So I'm going to bring the 40 over to the right side by adding it so that it goes away on the left. And I'm going to bring the 10x to the left side by subtracting it so it goes away on the right. Then we have 5x minus 10x, which is negative 5x. We've got negative 30 plus 40, which is positive 10. And then last thing to do here, divide by negative 5, right? Because the operation is times with the x. And again, coincidentally, I think we have another solution here of x equals negative 2. I should find different examples probably, but not always the case, right? You'll get different numbers, but again, there's our solution to this. Okay, now we can also solve equations for different variables if there may or may not be some numbers involved. So for example, here's an equation that says P times V equals N times R times T. And maybe we want to write this with R equals instead. So you just treat the letters as they would be treated as if they were numbers. So if we want to get R equals, like just in the end, right, I want to have R equals something. It's already over here on the right side, so I might just have it backwards. Like in the end, we'll have R equals some stuff. But I want to get rid of the N, and I want to get rid of the T. It's times by the R, so I can, in one go, just divide by N, right? That's going to cancel that out. I got to do it to the left side too. And then I can also divide by T, and that's going to sort of be divided by N times T on the right side, and I can do that over on the left side as well. Right, so that will give me just one R on the right, and then I've got PV over N times T, and we accomplished the goal, right? That's just written as R equals, so that's our answer, PV over N times T. Okay, number 2, we've got P equals 2L plus 2W, and we want to solve this for L. So you might recognize this as the perimeter formula for a rectangle, and we want to put it in as L equals. So we've got a little two kind of like terms here. So we want to first try to isolate this part so that we can undo the multiply in the end. So I'm going to bring this 2W over to the left side. And we'll do that by subtracting. On the left side, we can't combine these together because they're not like terms. So I just have P minus 2W equals 2L. Now this is almost solved for L. I've got to do divided by 2 now. That gives us L equals on the right. I've got P minus 2W, and then that's divided by 2. And you might think that these 2's can cancel. That's not quite the case because we are also dividing the P by 2 and the 2W by 2. And if you cancel these, then you're kind of like forgetting that the P also needs to be divided by 2. So this is the best way to write this, I would say. But if you are like really interested in canceling out that 2, you could write it as P over 2 minus 2W over 2 if you want, so that you are truly dividing both of those things, the P and the 2W by 2. And then here you can cancel those 2's out and write this as P over 2 minus W is equal to L. So either one of these is fine. I would say this one's good, but if you prefer and really want to cancel out those 2's, then just be careful with doing that and making sure that you do divide everything in the numerator by the 2. All right, number 3, we have H equals 5 over 2 times B minus 20, and we want to solve this for B. So you have 2 options to start. You could distribute the 5 over 2 into the parentheses. That would be fine, but I'm just gonna like say we don't even need to do that. We just want to get this out of the right side, right? So to do the opposite of 5 over 2, we could divide by 5 over 2 to cancel this out. But a faster way to do that is to multiply by the reciprocal of 5 over 2, which is 2 over 5. Right, what that will do is cancel out the 2's, cancel out the 5's, and we'll just have a 1 left over. And if I do that on the right side, I also just have to do it on the left side. Okay, so I can say 2 over 5h, and then I just have 1 times b minus 20, and I can get rid of those parentheses. Okay, so this is the main thing to do here to get rid of a fraction. You could, do divided by 5 over 2 like this, cancel that out. But we don't really want to be dividing by fractions. We would then need to keep change flip, and that would make us multiply by 2 over 5 anyway. So last thing to do is just add 20 to both sides. And then we have b on the right, 2 over 5 times h plus 20. Those aren't like terms, right? So we can't like combine them or anything. And so there's our equation solved for b, 2 over 5h plus 20. Okay, I've got 2 more of these. How about number 4 is a equals p plus prt, and we want to solve this for p. Now this one's different because we have p here and p here, and I guess it would partially be true to solve this for p if we were to subtract prt, right? We would get p equals, we'd have to do that over here, a minus p times r times t. And you could say, okay, I solved it for p, but it doesn't make sense to have p equals and then an equation where you also have p in it, because you want it to like have an expression for capital P without having P itself in the equation, right? So this is a theme that comes up sometimes to kind of like, I don't know, combine these together or make it so that you have one of them instead of two of them here. Notice that on the right side, there is a GCF of AP. So let's factor it out. When we do that, we're dividing, right? So we're divide this by P. That becomes a 1. And when we divide this by P here, we just have R times T left. Right, if I distribute this in, I will end up with where we started. And so this is GCF, right? That was the P was the GCF of the right side. Now this is multiply by P times 1 plus RT. So to solve for P, what we'll do is just divide by 1 plus RT, right? And this will cancel that out on the right side. And on the left side, we can't do much to simplify that or anything, so we'll just have to write it as A over 1 plus R times T, and then that is equal to P. And this is our equation solved for P. All right, number 5 is similar. See if you could pause this and try to solve this equation for W. I don't expect you to know this, but this equation here is the surface area of a like a box with length, width, and height. And we want to solve this for W. So again, the W appears in 2 places. However, on the right side, we can't just factor out a W because it doesn't appear in this term. So the first thing that we'll have to do is just bring this over to the other side so that then with these 2 terms, we can actually factor out a W. So let's do that to start. Let's do minus 2LH from both sides. On the left side, those aren't like terms, so we'll just have to write them just like this. And now that we have done that, we can factor out a W, right, as a GCF from the right side. So what we'll have is W times, and then 2L plus 2H. And then to solve for W and finish this up, we will divide by what is multiplied by, right, the 2L plus 2H to cancel it out from the right side. So on the right side, we have just W equals, on the left side, A minus, and it looks crazy, A minus 2LH divided by 2L plus 2H. And I don't know, we have minus, divide, plus. We can't cancel these 2's out or anything for the same reason we couldn't in the other example. This is minus, this is divide. They don't undo each other. We can't cancel these L's for the same reason. These H's can't go for the same reason. And so this is, I would say, good enough. Like, we can't do anything else to simplify that. Okay, the next type of equation that we will look at solving is absolute value equations. So we just solve linear equations, which means x to the first in your equation. And these ones also have x to the first, but they also involve an absolute value. So just absolute value of something equals number over here. And so the way to solve this is to isolate the absolute value term, meaning get it alone on one side of the equation. Then what we will do is split this equation to get rid of absolute value into x equals positive a and x equals negative a. And I'll show you why we do that just in the first example. Then the last thing to do is just solve each equation, each of these for x. So in example 1, we have the absolute value of x equals 7. Now to solve, that means we're looking for an x value here that makes this equation true. So maybe you can look at this and say, okay, well, absolute value of 7 is 7, but also negative 7 has absolute value of 7. And that's exactly why we want to split the equation into these two things, right? So the split means that to get rid of the absolute value, you make two equations. One is with your inside of the absolute value, equals the positive version of whatever's on the right side. And the other one is that the inside of the absolute value equals the negative version of what was on the right side, so negative 7. The last step here is to solve each equation, and they already are solved, right? It's just x equals. So these are often having two solutions, so we'd say 7 and negative 7. Right, and just to give you like a picture what that means, right? Absolute value is distance on the number line. And so from 0, so we're looking at numbers x such that the distance from 0 is 7. And of course, there's going to be two numbers, right? Negative 7 and positive 7. And so that's why we split it up into those two equations when we get rid of the absolute value bar. So that one's kind of maybe easy to visualize, but in the case like number 2, where we have two absolute value of x plus 5 equals 9, it's a little bit harder. So the first step I said was to isolate the absolute value. And so what that means in this case is first I've got to do minus 5 on both sides. Basically want to solve for absolute value of x to start. So that gives us 2 times absolute value of x equals 4. And this isn't quite solved for absolute value of x now. We've got to do divided by 2 first. And that gives us absolute value of x is equal to 2. So once we get here, we split this up. We get x equals, no more absolute value. One of them gets the positive part of the right-hand side, positive 2. The other one gets the negative of the right-hand side, negative 2. And once we have this, we're solved for x, we are done in this case. So those are both of our solutions. All right, let's try two more here. Number 3, we've got the absolute value of x minus 2 equals 3. And now this one's different because inside of the absolute value, we have more than just x. But we'll still follow the same steps. So the absolute value is already solved for. So we don't have to do that. So we'll just go straight into splitting the equation into 2. We get what's inside of the absolute value, which is x minus 2. And then one of them, we could have the inside here, right, be positive 3, right? Absolute value of 3 is 3. So that's the one equation we'll solve. And then absolute value of negative 3 would also equal 3, right? So we want to also see when is the inside equal to negative 3. Now here we have to do a little more work. We'll have to solve each of these. So we'll do plus 2 to this first equation. That gives us x equals 5. Same thing, plus 2 to the other equation. And that gives us x equals -1. So these are our solutions to this equation. Both of these will work, 5 and -1. All right, the last one here is 1 minus the absolute value of 2x plus 5. So same thing applies. We want to first isolate the absolute value. So let's do -1 on both sides. That will give us negative absolute value of 2x plus 5 equals -15. And I do have to truly isolate the absolute value. So to get rid of that negative in the front, we'll do divided by -1. So that gives us the absolute value of 2x plus 5 equals positive 15. Right now, here is where we will split this up into two equations. The inside could be positive 15, or the inside could be negative 15, right? And in both of those cases, we would have the absolute value to be positive 15. Okay, we gotta solve each of these. So -5, -5 in the first one gives us 2x equals 10. Divide by 2, divide by 2. That gives us x equals 5. And then same thing for the other equation, -5, -5. On both sides, we have 2x equals -20. And then we'll divide by 2 to solve for x. And that gives us x equals -10. Okay, so again, two solutions, 5 and -10 are the answers to that equation. Okay, so solving linear and absolute value equations has its own method, and solving quadratic equations has a couple different ones. So quadratic, what this means, like linear means degree 1 on the x, like x to the first, right? That's its degree. Quadratic means you've got x to the second. I guess it could also have an x to the first in there, but the biggest, the leading term has a degree of 2, right? So I should say here, the leading terms, the highest degrees in that appear for a quadratic is 2. So the way to solve these is different. So this is very important to understand that this method is totally different than, well, at least to start, than what we've been doing. So you want to first get 0 on one side, like get everything on the left side, all terms involving x or numbers, and then 0 on the other side. Then we factor the side with the terms on it all the way, completely, 100% factored, can't factor further. And then what that will do is give us, multiple things that are multiplied together to give us 0. And that's important because if you multiply two or more things together and you get a 0 out, the only way that that can happen is if one of those things you multiplied is 0 itself. So what we do then is we set each of the factors equal to 0, and you solve those for x. Okay, so for example, number 1, we have 6x squared equals 15x. Now I know it's tempting here to like divide the x maybe, but this is a quadratic equation. We have squared here, that's our biggest degree. So we have to follow this. We get 0 on one side, so I'm going to do minus, I'm just going to bring the 15x over, minus 15x. Now that's going to give us 0 on the right side, which is what we want. And on the left side, those are not like terms, so we can't subtract them. We just get this 6x squared minus 15x. So we've accomplished the first thing. Now we want to factor the left side all the way. And you have to remember all of the factoring techniques that we've discussed. So the first thing is to look for a GCF. And this one has a GCF of an x and also a 3. So we'll take out a 3x, and what we're left with is a 2x and then minus 5. Still equals 0 on the right. When you are factoring out a GCF, that's normally like as good as that will get, but then you look at what remains and you see if it factors further. I've got two terms. The only way that's factorable is if it's a difference of two squares, and this isn't because we have x to the first. So what we'll do now is move on to step number 3, which is to set each factor equal to 0 and solve. Okay, so we're going to take the 3x, we can group that as one factor, and then it's times 2x minus 5. So we set 3x equal to 0, and we set 2x minus 5 equal to 0. And we solve each of these for x like we're solving linear equations. So in the first one, we'll do divided by 3. That gives us 1x on the left, and 0 divided by 3 is 0. So x equals 0 is one of those solutions. Then in the other equation, we've got to do plus 5 to start. That cancels that out on the left side. That gives us 2x equals 5. And then we will divide by 2 on both sides to cancel the 2 out and get 1x on the left. And that gives us x equals 5 over 2. Now, both of these are answers, x equals 0 and 5 over 2. If we plug those in to this here, or this, or the original, we will get a true equation, right? And you can kind of tell it's easier to plug that in here. If we have a 0 in for x, this would be 3 times 0, 2 times 0 minus 5. I actually don't care what this is here, because the second I multiply it by 0 here, the whole thing will be 0, right? That's the idea of this. When you plug in a 5 over 2, that will make this factor equal to 0. I don't care what this whole thing is. Times 0 will give us 0. All right, number 2, we have x squared minus 3x equals 10. So this is again a quadratic. We've got a squared on as our leading term. We have to follow the rules here and get 0 on one side. So let's do minus 10 on both sides. That will cancel it out on the right. We have x squared minus 3x minus 10, and then equals 0. Okay, now to factor the left-hand side here, this is 3 terms, trinomial, no GCF, so there's a 1 in front of the x squared, so we can try to reverse FOIL this. So that's where we say, okay, this is going to factor into 2 binomials, x, x, and we look for numbers that will multiply to the negative 10 and add up to the negative 3. And those numbers are, I believe, minus 5, negative 5, and plus 2. Okay, so now no factoring further to do, so we'll take our x minus 5, set that equal to 0. We take x plus 2, set that one equal to 0, and solve each of these for x. First one, we do plus 5 on both sides. That gives us x equals 5. Second one, we do minus 2 on both sides. And that gives us x equals negative 2. And again, both of these are answers, so we take both of them 5 and negative 2. All right, number 3, we have 5x squared equals 8 minus 18x. Got another quadratic. Squared is our biggest degree, so we want to get 0 on one side and then factor completely. So I know that it might be less work to bring this over here, but we generally like to have positive numbers in front of the x squared. So I'm going to do minus 8 plus 18x to get 0 on the right. There's no like terms to combine, so I'm just going to write this as 5x squared plus 18x minus 8. And then on the right-hand side, we have 0. Now this is a trinomial, 1, 2, 3 terms. There's no GCF to take out. So I look and I see the number in front of the x squared, and that is not a 1, it's a 5. So I've got to use the AC method. So that's where we take a times c. In this case, that's 5 times -8, which is -40. And then I look for numbers that multiply to -40, but add up to +18, the b value here. So I don't know, we've got 10, -4, -4, +10. Those are no good. Those add up to 14 or 6. And let's see, 8 and 5. One's got to be negative, one will be positive. Those don't work, they're 3 apart. 2 and 20. I think those are our winners, right? We've got +2 and -20, right? These add to +18. So what we do now is we take the bx term, the middle term here, and we're going to split this up using the numbers we found. So we've got -2x plus 20x. Doesn't matter the order. So if you wrote it in the other way, that's okay. Then the 5x squared and then -8 just come down and remain. Now what we've done is split this up into 4 terms. So we do factoring by grouping. The first 2 terms have a GCF of an x, and the second 2 terms have a GCF of a 4. So with grouping, we take out the GCF within each group. So I'll take out an x in the first group. That leaves me with 5x minus 2. In the second group, I take out a 4. That leaves me with 5x minus 2. And looks like we did this right because now these match. So you factor out the overall GCF, which is the 5x minus 2. And then what we're left with is x and then plus 4. Excuse me. Then we have now fully factored this. Right? So now we take our 5x minus 2. We set that equal to 0. If that's 0, it makes the whole product 0. And also if the x plus 4 is 0, that makes that whole product 0. So we've got 2 little equations to solve. We'll do plus 2 on the first equation. That gives us 5x equals 2. Divide by 5. I am running out of space here. This gives us x equals 2 over 5. Then in the second equation, minus 4 on both sides. That cancels out the 4 on the left. And that gives us x equals -4. So those are our 2 solutions, x equals 2 over 5 and x equals -4. Here are some special cases with quadratics. If you have an equation, this is shorthand for equation EQN is x squared equals something, where this is a number, then the solutions are just the positive square root of this number and the negative square root of that number. So we'll talk about this in a minute, but let's look at examples of this. So in number 1, we have x squared equals 25. Right, so to solve this, you're looking for numbers such that when you square them or multiply them by themselves, you get 25. And of course, 5 squared is 25, but also -5 squared is 25, because negative times negative equals a positive. So if you recognize that this is equal, it has the same, like format as I'm saying here, then I know we haven't talked about square roots yet, and we will in the next unit, but what this is saying here is that you can say, okay, x equals the square root of 25, and x equals the negative square root of 25, and that's 5 and -5. So here are the 2 solutions to that. Right, alternatively, you could use what we were doing before. And for this, something simple like this, I don't know, I like showing why this is true. You could get 0 on one side by subtracting 25. And then here we have a difference of 2 squares, and so this factors into x plus 5 times x minus 5. And this illustrates why we get 2 different solutions, right? Because when you set this first factor equal to 0, this would give you x equals -5, and this factor gives you x equals +5. So that way also shows you why you get two different answers. Okay, number 2, we have x minus 2 squared in parentheses equals 7. Now, in this case, this kind of method might be more useful or easier to use, right, than I have here because um, this isn't just x, right? It's more than just x. And if you were to go about this in this other method of getting 0 on one side, you'd have to like FOIL this out first and then get 0 on one side and try to factor, which is a little more tedious than just doing this method that we've got here. So first what we'll say is we have x minus 2 would equal the square root of 7, which isn't, it's an irrational number, so I'm just going to leave it like that. And x minus 2 equals the negative square root of 7. Right, then to solve these, you would just do plus 2 cancels out on each of them. I gotta do it on the other side as well. And so we have x equals radical 7 plus 2. And x equals negative radical 7 plus 2. These are exact answers, so you should leave them like this. Don't round them in your calculator on a homework or a quiz or exam or WebAssign or anything, unless you're specifically asked to. So this is good. Right, the last one of this kind is 2x plus 1 whole thing squared minus 3 equals 13. This doesn't quite look like what I was describing above, but it can if we just do plus 3 first. Right, that will give us 2x plus 1 squared equals 16. Now I can split this up. I get 2x plus 1 equals the square root of 16, and 2x plus 1 equals the negative square root of 16. Square root of 16 is 4, so I have 2x plus 1 equals 4, and 2x plus 1 equals negative 4. Now I just solve each of these for x, right? So we'll do minus 1, that gives us 2x equals 3. Divide by 2, that gives us x equals 3 over 2. Okay, same thing on the other side. We'll do minus 1, 2x equals negative 5. Divide by 2, and that gives us x equals negative 5 over 2. Again, these are both answers, so we'll just put an and between them, and those are our solutions. Okay, there's one other thing to discuss in quadratic equation solving, and that is the quadratic formula. So this solves a quadratic equation set equal to 0 for you, and you should only use it if the equation is not factorable, then you use this. So just to remind you, you need it to have to be of this form: ax squared plus bx plus c equals 0. And the equation is solved for x already, so it's x equals negative b, the same b here, without the x, just the number, plus or minus, square root, and then we've got b squared minus 4ac, and then that's all divided by 2a. And again, the a, the b, and the c are just the numbers in the places where we write it like this. If you have this memorized, great. If you don't, there is a Pop Goes the Weasel song. I'm not going to sing it for you, but you could go find it online to help you memorize this. I do expect you to, at some point, have it in your brain. So let's do two examples using this. Number 4, we have x squared plus 8x equals negative 3. So try to factor it first. Like, let's get 0 on one side. We'd have to do that regardless. So we'll do plus 3. That gives us x squared plus 8x plus 3 equals 0. Now this is a trinomial, there's a 1 in the front, so we could try to reverse FOIL this, right? Where we have x, we need numbers that multiply to 3 and add up to 8. And the only numbers that multiply to 3 are 1 and 3, and they don't add up to 8, right? So that doesn't mean there's no solutions. It just means that the solutions may be irrational. So a a radical of some kind that doesn't simplify into a fraction or a whole number. Okay, so let's just see. We've got the A is 1, the B is 8, and the C is 3. So to solve this, we started out as x equals negative b, negative 8, plus or minus square root b squared, 8 squared, minus 4 times a, which is 1, times c, which is 3, and that's all over 2a, which is 1. Now to simplify this, we want to do as much as we can sort of by hand. So I would say doing the inside here first is a good start. So 8 squared is 64. 4 times 1 times 3 is 12. And 64 minus 12 is 52. So we've got the square root of 52, and that's all divided by 2 times 1, which is 2. We will talk about how to simplify radicals like this in the next unit. As a quick intro into that, basically, so 52 is not a perfect square, so it doesn't have a quote unquote nice square root, but there could be a perfect square hiding in it as a factor. So the perfect squares are, I think we talked about like 1, 4, 9, 16, 25. So you want to see if you can divide 52 by any of those, and 25 doesn't work. 16, I don't think works. 9 is not going into 52. 4 seems like it does. So 4, let's see, 52 is 4 times, but 10 will get us to 40. I need 12 more to get us to 52, so 13. And so the square root of 52 can be written as the square root of 4 times 13, and then the 4 can come out of the square root, but it's got to become a 2. So it's going to be 2, and then square root 13 has to stay, so 2 root 13. Again, we'll talk more about this as we get into the roots unit. So if you can get here, that's great right now. This is just a little bit of a, I don't know, introduction into that. So what we're going to do is split this up into 2 different solutions because we have this plus and this minus. So the first one is negative 8 plus, the next one will be negative 8 minus. And I'm going to write this as 2 radical 13 divided by 2, and 2 radical 13 divided by 2. The last thing we can do here to simplify is to actually, in this case, cancel out the 2. We can do that because this part and this part are both divisible by 2. So I'm going to cancel this 2 out here with that one, and then this 8 will become a 4. The 13 radical doesn't matter, it's times by the 2. So this 2 here takes care of the dividing by 2, and then the 8 is separate. We can divide that by 2. So same thing in the second root, we'll cancel that out. That should be just a 1 there. And then the 8, negative 8 will become a negative 4. So we can just write this as negative 4 plus radical 13, and then negative 4 minus radical 13. And these are our 2 solutions. X equals both of those numbers, and we don't want to do anything to change them by making them decimals. We want them exact as possible, so this is good. So let's try one more of these. 2x squared equals 4 plus 7x. So let's get 0 on one side, do minus 4 minus 7x. The right side, that gives us 0. The left side, I'm just going to put this in standard form. So we'll do decreasing power order. All right. So let's see, is this factorable? Well, if it were, we would need the AC method. So we'll do 2 times -4, which is -8. And any numbers that multiply to -8 and add up to -7, and there are such numbers, right? -8 and +1. So this is actually factorable. Let's factor it quickly, and we can see that we do get the same answer either way. So I'll just go through this really quickly because the point of this is the quadratic formula practice, not the AC method. So what this would say is we would split this up into 2x squared minus 8x plus 1x minus 4 equals 0. Take out the GCF of the first two terms and the second two terms. The GCF of the first two is 2x. The GCF of the second two is 1. Then we take out the x minus 4 and we're left with 2x plus 1. And we set each of these equal to 0. This gives us x equals 4. And this gives us x equals -1/2. And I know I went through that really quickly and didn't show a lot of work. You should try this on your own and fill in the gaps, just showing you that this is what we should also get with the quadratic formula. Okay, so let's practice using it again. Here's our A, here's our B, -7, and C is -4. So we start with x equals, right, -b, -7. Okay, plus or minus square root of b squared, parentheses, -7 squared, minus 4 times a, which is 2, times c, which is -4, and that's all over 2 times a, which was 2. All right, some simplifying to do here. We'll do -7, that's +7. We should do the simplification of what's inside of the root. So let's see, -7 squared is +49, minus, see, 4 times 2 is 8, times -4 is -32, and we're subtracting it, so we'll end up with adding 32. 49 plus 32 seems to be 81. And so what we have here is the square root of 81, and that's all divided by 2 times 2, which is 4. Now in this case, the 81 is a perfect square, which is why we are getting nice rational answers when we are able to factor. So this will be 7 plus or minus 9 divided by 4. And at this point, we can split this up into two solutions, one with the plus and one with the minus. So 7 plus 9 is 16. 16 divided by 4 is 4. Hey, look, that matches. Has to, that's how math works. 7 divided minus 9 is -2 divided by 4, and that simplifies to -1/2. Hey, that matches here and here. So either way, these are our two solutions, x equals 4 and x equals -1/2.